Hi, I am Nurshahzlydia Binti Mohamad Yusaini, KIB1006, and my other three groups member decides to do projectile motion in 2D, which is hitting a golf ball for our dynamic video group assignment. First thing first, what is projectile motion? Projectile motion is a motion experienced by a particle when it is projected or thrown near the surface of Earth along a parabolic pathway, subjected to the action of gravity only. The parabolic pathway is called trajectory and the particle is called projectile. The constant acceleration due to gravity force in the projectile motion is 9.81 meter per second cube. So, in this video, we will demonstrate how hitting a golf ball explain projectile motion that consists of vertical and horizontal component in which the ball travels under constant acceleration due to gravity force, which is 9.81 meter per second cube. This is the problem that we want to focus on when hit the golf ball, which is hitting a golf ball pass over the bunker hill. So what is the bunker hill? The bunker hill is this hill, as you can see, and it is used as challenge in playing golf. The diagram that we have choose related to the problem earlier is this diagram, which will give all the information that we are going to use for the problems later. So the situation is Justin is practicing his golf skills. After several attempts to adjust the angle to hit the 45-gram golf ball, he barely got to hit the ball just to pass over the top of the bunker hill at angle 30 degrees, as in the diagram. Hence, find the time when the ball passed the top of the bunker hill. Assumption neglects the small distance between the ball and the top of bunker hill. So for projectile motion, we can distinguish it into two components, which is x component and y component. For x component, we are going to use the equation x final equal to x initial plus v initial time by t. Okay, after insert the value x final 3, x initial 0 plus v initial cos 30 degree t, VO you will got this equation 1. And then work on to y component. We are going to use the equation y final equal to y initial plus v initial t minus 1 over 2 acceleration due to gravity times by t to the power of 2. Then we substitute the value y final 1.5, y initial 0 plus v initial sin 30 degree t minus 1 over 2 9.81 times by t to the power of 2. We will got the equation 2 for this y component. Okay, then we substitute equation 1 into equation 2. We will get 3 sin 30 degree t divided by cos 30 degree t equal to 1.5 plus 4.905 t to the power of 2. T we will got 3 tangent 30 degree minus 1.5 over 5 over 4.90905. Then T we will got 0.218 second. To find the velocity initiate when Justin hit the ball, we will use equation 1 from previous question and the value of T, which is 0.218 from the that we got from previous question. We will got initial velocity 15.89 meter per second. And for the FVD of the ball, we can now do it because we got the VO. VO equal to 15.89 meter per second. We can distinguish it into X and Y component.
My name is Hasya from Nasir, KIB1002. Now we're going to continue from the part from my friend Lydia has calculated just now. Okay, now we are going to find the velocity of the golf ball when it passes the center top of the bunker hill. we can use the formula V final equals to V initial minus AT. The value for V initial and T has been calculated before, so the value we just insert it into the formula, and the final velocity we will get 13.751 meter per second. Okay, and then when the golf ball passes the hill, it will land on the ground, or known as the putting green in the golf term. So when the ball landed on the ground, we can find the time taken to reach the ground. So we use the formula VFY equals to V initial Y minus 18. VFY is 0 because when the ball reaches the ground, the velocity will become 0. Then the V0Y, we use the V initial that we have get, and the A we use the gravity acceleration, and then we can find the T. So the T that we get is 1.62 seconds, which is the time is half of the projectile motion. To get the total time, we need to times the T with 2, and we will get 3.24 seconds. Then the final velocity, we can calculate it by using the formula that we have used in the first question just now. We use the VF equals to V initial minus 18. The V initial is the same that has been calculated by Lydia, which is 15.89 minus the gravity acceleration times T. The T that we use is the total time, which is 3.24, and the final velocity that we will get is negative 15.89 meter per second. The negative is because the ball is downwards. And we can find the total distance traveled by the ball. We use the formula X final equals to X initial plus V initial x T. X is the distance, and the X initial is 0 because the ball started from 0, plus 15.89 cos 30. We need to put the cos 30 because we are using the velocity at the x-axis, and T is 3.24. The distance that we will get is 44.586 meter.
Hi and good morning. My name is Naili Binti Mustapha, KIB1006. So in this slide, I will continue with the question 2D. The question given is, the ball rose to the right 2 meters after it landed and then stopped. With the force of 3.6 Newton, Justin hit the golf ball horizontally as shown in the figure 2 to make it roll into the hole. We need to find the velocity of the hit ball. Assumptions: neglects the friction force caused by the ground and the rolling ball. Also, the force is assumed to the left is positive. So, from the figure, we need to find the distance of the ball from the holes, which is the value we get from the previous slide, 44.586 meter. We need to add with 2 meter and minus with 25 meter, which is 22 plus 3 meter, and we get the value is 21.586 meter. Then we substitute in the formula U1 minus 2, which is distance multiplied with the force, which is 3.6 multiplied with 21.586, and we get the result is 77.71 joule. By using the principle of the work equation, we substitute T plus U1 minus 2 equal to T2. So, we know that T1 is 0. We plus the value of U1 minus 2, which is 77.71, equal to half multiply with 0.045 multiply with velocity squared. Then we calculate and get the velocity, which is 58.769 meter per second. Next, we move to the next slide, which is question 3. The question given is apparently the ball does not get into the hole on the first try. Based on the figure 1, improve Justin in performance by A. Determining the increment of angle needed for the ball to get into the hole without changing the initial velocity. 30 degrees needed to pass over the hill. Hence 30 degrees plus theta to shorten the distance range. First, we need to calculate the S component by using this formula. We substitute 25 is equal to 0 plus the velocity 15.89 from the previous slide, multiply with cos 30 plus theta, multiply with t, and we get this equation for equation 1. In the y component, we use this formula and we get 0 is equal to 0 plus 15.89 sin 30 plus theta t minus half multiply with 9.81 t squared, and we get this formula as the equation 2. Then we need to substitute the equation 1 into equation 2 and we get 25 over 15.89 cos 30 degree plus theta multiply with 15.89 sin 30 degree plus theta is equal to 4.90525 over 15.89 multiply with cos 30 plus theta squared. So we can solve this simultaneous equation and we get the theta, which is 8.12 degree. That's all for me. Thank you.
My name is Natasya Binti Jalil with matrix number KIB1006. So now I'm going to continue the presentation with question 3b, which is to determine the initial velocity needed for Justin to hit the ball into the hole when the angle is still the same, which is 30 degrees. So first we solve in the x component by using equation xf equal to x0 plus v0 in the x component times t. So we have the final x, which is 25, and the initial is 0. v0 is what we want to find, cos 30 in the x component here, and t. So we make t as a subject and we get equation 1. So next we'll solve in the y component by using this equation. So yf and y0 is 0, and then v in y component is v0 sin 30 times t minus 1 over 2 ac, which is 9.81 times t squared. And then we will have this equation and we can substitute equation 1 into equation 2 here t. So we substitute equation 1 into equation 2 and we will get this equation. So we will do some calculation here, and at the end we will get v0 equal to 16.828 meter per second. So this is the initial velocity that Justin needs to hit in order to get the ball into the hole, besides by increasing the angle in question 3a. Now, assumption taken by us in this problem and discussion. In question 1, we neglect the small distance between the ball and the top of the bunker field, and in question 2d, we neglect the friction force caused by the ground and the rolling ball, and this too is in order to ease the calculation and we want to get more accurate answer. The effect due to the curvature of the Earth and the rotation of the Earth is also negligible. And then we assume the entire trajectory is near the surface of the Earth. And last, we assume that the acceleration due to the gravity, which is in a vertical direction motion, is constant with a magnitude of 9.81 meter per second square. So last is a conclusion. A projectile is an object that moves due to the only constant gravity force, which is the acceleration gravity 9.81 meter per second square that acts vertically. Then we also able to see clearly how hitting a golf ball can be explained by using a projectile motion and also by considering several assumptions. The vertical motion shows acceleration due to the gravity applied the velocity in that motion, which is the 9.81 meter per second square. Meanwhile, the horizontal motion describes the tendency of any object in a projectile motion to remain in a constant velocity. And thus, we also can improve the performance by either changing the initial velocity or changing the angle to hit the golf ball. So, by knowing the initial velocity and the angle, we can find the x and y component, and we can investigate the projectile motion by calculating the range of the projectile, the golf ball, and so on. And in this calculation and problem, we solve them by using appropriate and suitable projectile equation motion. And I think that's all from us. Thank you.